So in this video, we will see what is meant by modulation and what are the different types of modulation. Okay. So before going on to the topic, you have to know why do we need this modulation. Okay. So you know that communication means transmission of the information from the source to the destination. So transmission of your information is nothing but your message signal, which is a low frequency signal. So if we take a long distance communication, since the message signal is not compatible to be transmitted in the same way through the medium to the destination, what we require? We require a carrier signal which can carry this message signal through the medium to the destination and transmitted to the destination. So this process of superimposing the message signal onto the carrier signal is called as modulation. So let me put it in this way. Okay, so this part A is showing a small example where let us assume that you are going for a trip from Bangalore to Mysore. Okay, and so you are selecting a roadway. The channel is going to be your roadway. So you will require a carrier which can carry you all to the destination. So your car is your carrier signal. So your car will carry all the message signal, that is all of you, and it will pass through the channel, that is through the road, to your destination. In the destination you will be separated from the car. Okay, same way in the communication system also, your message signal, that is your low frequency signal which has to be transmitted, will be carried by the carrier signal, which is a high frequency signal. Okay, so your waveform itself gives you the difference. Low frequency signal means less number of cycles, right? Less number of cycles. High frequency signal means more number of cycles. Okay, so carrier signal, message signal, carrier signal. Now your carrier signal will carry the message signal and it will pass through your channel. Channel is nothing but, so now it will become a modulated wave, and the modulated wave will be transmitted through the channel. So the channel can be wired or wireless to the destination. In the destination, your carrier signal will and the message signal will be separated to each other. So in the transmitter, you will be having the modulation, mixing of or superimposing your message signal onto the carrier wave, and in the receiver, you will be having the opposite of your modulation, which is nothing but your demodulation. Okay, so this is your introduction to your modulation. And now why do we need this modulation? The main important points are, in order to reduce the height of the antenna, okay, reduce the antenna height, and the second one, in order to avoid the interference or mixing of different signals. Okay, so let me put it in this way: in order to avoid the interference, to increase the range of communication, to allow multiplexing of the signal, and to increase the quality of the reception. So these are some of the important points. Why do we go for this modulation? Moving on to the next slide. So here let us see the different types of modulation. So based on the type of the message and carrier signal, you can classify your modulation mainly into two types. One is called as your continuous wave modulation or analog modulation, and the second one is your pulse modulation. So in this case, now we can take the two signal. One is your M of t and the second one is your C of t. Okay, if M of t is analog and your C of t is also analog in nature, then it comes under the category of your continuous wave modulation or angle modulation. Whereas if your carrier signal is, if your message signal is analog, okay, and if your carrier signal is a train of pulse, then it comes under the category of your pulse modulation. Here your carrier signal is a train of pulse. Okay, pulse train, carrier signal. So then it comes under the category of your pulse modulation. So your continuous wave modulation or analog modulation can again be divided into two types. One is called as your amplitude modulation and the second one is called as angle modulation. So what is meant by, in general, you know what is meant by modulation. If any characteristics of your carrier signal, the characteristics of carrier signal is varied with respect to that of your message signal, then it is called as your modulation, right? So what are the different characteristics of carrier signal? One is your amplitude, frequency, and your phase. Depending on this, you can have the classification. One is your amplitude modulation, second one is your angle modulation. Angle modulation can be again divided into two types. One is your frequency modulation and phase modulation. So what will be your definition of amplitude modulation? If the amplitude of the carrier signal is varied with respect to that of the instantaneous message signal, then it is called as amplitude modulation. Similarly, if the frequency of the carrier signal is varied with respect to that of your instantaneous value of the message signal, then it is called as your frequency modulation. Now, what may be your phase modulation? If the phase of the carrier signal is varied in accordance with the message signal, then it is called as your phase modulation. Okay. So let me make it clear once again. Here both your m of t and your c of t is analog in nature, continuous in nature. Okay. So now, whereas in the case of pulse modulation can again be divided into pulse amplitude modulation, pulse width modulation or pulse duration modulation, and pulse position modulation. So if your message signal is analog in nature, if your message signal is digital in nature, if m of t is digital in nature, then you have one classification of your pulse modulation. It is called as pulse code modulation. Okay. So similarly, if your message signal is analog, here you have three classification, right? Amplitude, frequency modulation, and phase modulation. You can also add another classification that is called as digital modulation. So what is the difference between this digital modulation is that if your message signal is digital, if your m of t is digital in nature, okay, then you have this classification. What are the three classification? One is called as, it is called as keying methods: amplitude shift keying, frequency shift keying, and phase shift keying. Your message signal will be digital, but your carrier signal will be analog in nature. So these are the main different classification of your different modulation techniques.